All right, hey guys, I have received a question from one of y'all about a couple of items, so I wanted to go ahead and go over that with you real quick. All right, so we are going to be doing 17D, number 16. All right, 17D, number 16 says, all right, this is 17D, number 16. It says, find the number of sides in a regular polygon if the measures of the interior angles add up to 540 degrees, okay? So how many sides are there in a polygon whose interior angles add up to 540 degrees? Remember that we wind up with our polygons, the fact that we can take them and we can divide it into triangles, okay? And so this square, I have two triangles, 180 degrees and 180 degrees. So I would wind up adding those right there together. I get 6, I get 360 degrees, okay? So take that 360 degrees and, that's divided into 2 right here. This 360 degrees would be my total interior angles is 360 degrees, and notice that that has 4 sides. So if I was told that there were 360 degrees, I would divide it by 180, I would get 2. So I would know then that this is a shape that has 2 triangles in it, all right? So thinking about that, I would go this way. It has 2 triangles. If it has the 2 triangles, it's going to have 4 sides, okay? It winds up being 2 more. So let's see with this other one. I'm going to take this 540. I'm going to divide it by 180, and I'm going to get 3, okay? So then I find that this is a shape that I'm able to put 3 triangles into, and I get 3 triangles, and I get 5 sides. It's kind of always 2 more. There's always 2 more sides than there are triangles. So if I do this right here, okay, 1, 2, 3, 4, 5 sides, there's 1 triangle, and there's that. So there's 1, 2, 3 triangles here, okay? So that's how that's going to wind up going. So my answer was there are 5 sides. All right, the other one that we're going to work out here is exercise 17E, number 10. All right, and in this 17E number 10, they're looking at us finding the volume of a solid. All right, so we've got a pyramid here. We've got, here's the front of my pyramid. Here's the side of my pyramid. This is 21 millimeters. This is 21 millimeters, okay? They've got this line drawn down here, which that's going to be the height slant. That's giving you the height of the actual side of it as being 15 millimeters. And then I've got this line right here, which this is giving me my altitude. And my altitude there is 13 millimeters. Okay, I'm going to remember the volume of a pyramid equals, this volume is going to equal 1/3, and they have, the formula they give us is capital B H. All right, this capital B equals the area of the base, which is equal to the base, base squared. Base times base, okay? All right, so as I look at this right here, I'm going to wind up with my volume. It's going to equal 1/3 the area of my base, length times width, and here with it being a square, it's going to be 21 times 21, so 21 times 21, all right, times my height, and my height is 13, all right, so 21 times 21 is 441. Then that 441 times 13 could be huge, 5,733. And then I take that and I multiply it by 1/3, okay? And I'm going to get my volume equals 1,911 millimeters cubed. One thing I do want to point out for you guys, I think that there's an error, honestly, in the book, at least in my book, and mine's maybe a different printing than yours, back in lesson 15, when I look there, they give the equation for it, and it winds up showing in their example number 1, they say that volume equals 1/3 BH, and then they have that volume equals 1/3 3.14, 5 times 5 times 3. Okay, and if you look at their diagram, their base is 5 times 5, and the height is 3. I don't know why this is in here. And they wind up coming up with an answer of 25. Well, that 5 times 5 is 25, times 3 is 75, times 1/3 is 25. So I think that 3.14 is in there by mistake. And if you wind up looking down at the next one, at example 2, you'll see that they also have a 3.14 in there, which, you know, 3.14 is pi. And so that is not needed. Mind you, now I'm sitting there thinking about that with that one right there. What did I look at? There's the idea for that second one. Definitely for the first one, it's not needed. The second one, that second example, we're going to have that I need the area of the circle at the bottom, and area equals pi times the radius squared, right? Oh, so I might actually need that there, excuse me. So I do need that there. I need it in that one, but not in the other one, because I'm going to have pi times the radius squared, which is that 49 times the height. So I do need it there, but I think it's in error being in example 1 up there. Okay? All right, hope that helps. You guys work together on getting your stuff done. Okay? Y'all take care.
I can learn to understand you much better if